Welcome to Physics Secondary Revision, Lesson 18. The topic that the practical is set from is called Hooke's Law. Usually, when the instructions are given in the practicals, they need to be followed to the letter. Read the instructions carefully and understand them. Follow the instructions and guidelines provided in the paper. Use only the formulas provided. Verify that you have all the requirements or the apparatus before you start. Now, in this question 1, you are provided with the following: a micrometer screw gauge, a vernier calipers, a test tube, wire labeled M, a sellotape, 150 gram mass, some masses totaling to 40 grams, stopwatch, and triple stand. The strategy to follow in this question: study the requirements, make sure they are available, and try to link them to a particular content you have learned, e.g. Hooke's Law. Using a micrometer screw gauge, measure and record the diameter of the wire labeled M. And D is going to be the diameter in millimeters, then D in meters. So a micrometer screw gauge measures small lengths. It has thimble scale and the main scale. Reading must be in 2 decimal places. Fill your answers in the blanks. Using a wire M, make a spiral or a spring as follows. Use a small sellotape to fix one end of the wire M about 2.5 centimeters along the glass tube. The main thing here is to make a spring using the procedure provided. Hold firmly the part of the wire under the tape with one hand. Use the other hand to wind 30 turns as closely, as tightly as possible, as shown in figure 1. Study the figure and follow the connections as given. Build the setup as shown in the diagram. Remove the sellotape and release the spring from the tube. Bend the free end as shown in figure 2. Study the figure 2 and follow connections as given. Make sure you do not damage the spiral or the spring or interfere with the shape. Use a vernier calipers, measure and record the external diameter D of the spring, and record D is in millimeters and D convert it to meters. Check if there is a zero error on the vernier calipers. Measure outside diameter D of the spring. Record your reading in the space provided in 2 decimal places. Suspend the spring under 50 gram mass from a retort stand as shown in figure 3. Study the figure, follow it to make sure that you've done a proper setup. Put a 50 gram mass and note the initial length. Use an unparallaxed method to solve your problem. To read out, count and record the number of turns and note it as N of the suspended spring. Here you count the number of turns of the spring. The number of turns affects the spring constant, so be very careful. Add 40 gram mass to 50 gram mass and record the extension X of the spring due to the 40 gram mass. That will be noted as X in centimeters, and then you can convert it to meters. The extension is the increase in length after adding 40 grams. Work it out by using extension is equal to final length minus the initial length. Use an unparallaxed method here. To determine C, given that C is equal to 0.4 over X, make C the subject. So the value of C is worked out. Your answer must be in 2 decimal place and avoid unnecessary rounding off. The same, determine N by making N the subject. of the formula and in 2 decimal places, and do not round off. With the spring still loaded with 90 grams, pull the lower mass slightly down and let go so that the mass oscillates vertically. Record the time t for 20 oscillations. Determine the period t, which is the period. So repeat the process 3 times and get the average of the time. Period t is taken for 1 oscillation. Period t is the time taken for 1 oscillation. Stopwatch must be reset to 0 each time. To determine z, given that t is equal to 2 pi root the square root of m over z, where m is the mass of the kilogram in kilograms of the spring. Use the data collected earlier to evaluate z. Make sure your answer is in standard units and in 2 decimal places. Let's now start the procedure 1, part A. Put the wire between the jaw and close the thimble screw. Get the reading of the diameter of the wire and record. Reading on the thimble scale is added to the reading on the slip scale. So there you are, we have got 0.30 plus 0.05. We get 0.35 millimeters. So changing it into meters, it is 0.00035 meters. Make a spring by winding a wire around a test tube of more than 30 turns. Then remove the test tube. Count the number of turns and record. So there are 26 turns. Use a vernier scale or vernier calipers to measure the diameter of the coil of your spring. So measuring the diameter of the spring using a vernier calipers provided is about 8.0 times 10 raised per 3 meters. A stopwatch is to calculate the time taken for 20 oscillations. So we are going to do the oscillations. There you have the stand. We have got the figure. Measure the original length, which is 23 centimeters. Then the final length, when we add the masses, is exactly 26 centimeters. So the difference or extension is actually 3. That is 26 minus 23. So x is 3 centimeters. Now we start our stopwatch and do our oscillation. Be keen when you are checking on the stopwatch that is as it works. So t is 9.85 seconds, where t, the big T, that is the period, is 1 over 9.985 seconds, and it is 0.44 per second. The period time is now 0.44 per second. Then calculate the value of C using the value x as 0.03 as extension, and the mass is 0.4 kilograms as the added mass. So find the value of n using the formula given. Calculate z by substituting the value of t, and then we get z is equals to 4 pi squared m over t squared is equals to 4 times 3.142 squared times 0.9 over 0.44 squared. Z is 18. So I think that is the end of our